So we're going to talk today in particular about the Canadian Campfire, which is the Canadian Advanced Network for Astronomy Research, which is a research platform sort of similar to Data Labs. It started off in 2009, so quite a while back. And the idea is to provide a platform to process astronomical data from telescopes, and to provide sort of more power, compute power that you can normally get on a laptop or even a sizable tower into the hands of astronomers. It was developed by us, the Canadian Astronomy Data Center. It operates on hardware provided by the Government of Canada through the Digital Research Alliance of Canada. It provides significant digital resources, sort of hundreds and hundreds of cores, a few thousand cores, and hundreds of terabytes to astronomers. The original version we had was based on virtual machines. We're now moved on to we still have those, but we've moved on to providing a technology based on Docker containers. And what we provide is hardware, compute resources in the form of a remote desktop environment, notebook sessions, cartridge image viewer, storage that users control, and access control to all of the above, so that you can either keep your data private, data and software, keep your data private, share it with a team, or make it public. Now, when I submitted the abstract, the idea was to sort of increase usage of the thing that we've developed. Since the time I submitted my abstract and now, we've roughly doubled the number of people who are using this platform. So uptake has been extremely rapid. So I'm just going to walk you through a few screenshots of what it would look like if you were to use our platform. If this thing turns, there we go. So this is the opening splash screen, and there's a way of selecting what kind of compute resources you want, with sort of a pull-down menu that allows you to specify the type of session that you want to have, and how much memory, how many cores you want that session to have. And then walking through the individual session types. The first is sort of Python notebooks, which I think are familiar to a lot of people, that allow you to run sort of Python, and you're running your browser, but the Python is actually executing on computers at the CDC. The image viewer, come on.
Oh, just say next slide. I'll flip for you.
Thank you. Next slide, please. There we go. So this is the CARTA session. CARTA is a sort of like DS9, except it's perhaps more optimized for image cubes, and it allows you to look at sort of even terabyte-sized images or data cubes, but it only sends over the internet the parts of the image that are being displayed on the screen. So you can look at quite sizable images without actually without transferring them to your local machine. Next slide, please. This is the user storage portal that I was talking about. It sort of comes in two flavors. They're both named after large holes in the ground. There's Vault, which is our archival, slightly older archival system, where if you put files in there, they're replicated twice, so there's 3 copies total. So it would be there 20 years from now. And then Cavern, which just looks like a giant file system, and it basically is a giant file system, which is not backed up. On the other hand, the performance of that file system is a lot larger. And when people come in, they're by default given just a terabyte of space, but if they have a use case for larger allocations, they can get up to 100 terabytes, although that's pretty rare. 1 to 10 is sort of more common. But this allows you to, share data within a team or make it public. And access to the storage is via a browser or a Python client, or you can mount the whole file system so it just looks like a file system on your computer, or into one of the containers. Next slide, please. So the one I want to talk about a little bit longer is this remote desktop session. So it's browser based. So this looks like a screenshot from a slightly older Linux desktop. But if you look closely, it's actually running within a browser. And there you can see all my bookmarks up there. And so there's icons that you can click on and launch things, but each time you launch something, it's not running on the same, it's not like a computer. When you run stuff on your laptop, it launches stuff and it's still using the same resources on the laptop. Each time you launch something, you get access to another computer at the back end at the CDC. And then what software is available is, sorry, next slide, please. Is dictated by this applications menu at the top. And so it has sort of the normal things like a browser and whatnot, but under the Astro software, there is a whole bunch of preloaded, ready to go bits of software. So CASA for Alma, and then our Gemini, we have Dragons and Nifty, but there's also SST and various other things. Next slide, please. So when you launch it, it just looks like you're launching Dragons in your on your computer at home, except you're not. It's all running at computers at the CDC, but you have the same prompt, you have the same abilities. Next slide, please. So this is originally designed to be a kind of almost a demo, but not quite. And then you also have access to all the cool plotting tools that Dragons provides. And then, like I say, so if you launch this, oh, that's one slide too far. If you launch a Dragons container, you're getting, 16 cores, I can't remember, 64 gig of memory and whatnot. But if you launch a second one of these terminals, you're getting a whole new computer. They're not using resources at the back end that are the same. You're actually getting new resources each time. So it allows you to get an awful lot of compute power in a fairly lightweight manner. Next slide, please. And then again, the group management is the way that the access to all these things are controlled. The storage, the images, and in catalogs are all controlled through this one thing where the user can kind of in a fairly fine-grained way control who has access to what. In particular, what's sort of novel about our system is that allows one user to create a container that has all the software in it and then share that container with other people in his team or the public again, which makes it quite powerful. Next slide, please. So Gemini software on Campfire, one is Dragons. We currently have version 3.0.1 is installed. We will be upgrading to 3.0.2 shortly. When 3.1 becomes available, we will upgrade to that and make that available to everybody. The other piece of software we have is Nifty, which has been run on the NIFS archives and has produced science-ready data. And so instead of coming in and reducing your data, the data is actually sort of already ready to go, pre-reduced and ready to download. And the question is, what should you do next? Is there some other software that the user community would like us to install? One of the other ideas I have is, now that we've got Dragons installed and we've got a fairly sizable amount of compute resources, could we go through the entire GMOS archive, for example, and just process that and persist the results, and then make that available to the community as sort of science-ready data products, rather than you download the data, go through the archive and download the data and process it. You just download the data and it's ready to go. Which for other archives that we host at the CDC, so CFISH-T data in particular, and then back in the day, we also used to do an awful lot of HST processing, and we found that caused the reuse of data to be significantly higher. Next slide, please. So here's a list of reasons why you should use Campfire, and one is because it provides you access to significant resources with a fairly low, fairly flat learning curve. It's relatively easy to use. The software is already installed. Although we don't host the Gemini archive, we do actually have a copy of all the public data is hosted at CDC. So if you're going back to do archival research, that makes this a good choice. It's a cloud-based, so you can access it from any device with a browser. It's not, not tied to any one particular laptop or computer. You can actually do this from your phone if that's what you want to do. And then once you have produced the results, you can easily share those results with everybody. The problem perhaps with people who build science platforms is they're kind of like, I don't know, vegans or Catholics, and once they start doing this, they kind of want to proselytize everybody else. So I should say that, although I really like this, it's not necessarily what you need to do. If you have a small amount of data and a good computer, there's no reason for you to do this. But if you have a larger amount of data or you want to do a fair amount of processing, this is a good option. Next slide, please.
So maybe
Okay.
3 minutes or so. Oh,
Yep,
okay.
I saw the stars pop up. This is actually my summary slide. Sorry, it's 11:45 here in BC, in Victoria. I'm going a lot faster and not quite as doing quite as well a good a job as I might have been if I had actually traveled to Korea. This is my summary slide, and with the email address if you would like to use the Campfire Science platform. Thank you very much.
Thank you. Any comments, questions online? What do people think about having all the GMOS data fully reduced available? Right.
So I
Do
heard
you
the
ever-
question about,
Yeah. Hi. Nice talk. Thanks for giving it so late where you are. This is Janice. Do you ever have any virtual workshops to learn how to get set up on the system?
what has actually happened so far is it's grown very organically, in as much as it tends to be it'll be one person starts to use it and they'll, rather than us telling people what to do, one person will figure it out by themselves and then tell their buddies. So it hasn't, we haven't felt the need for a sort of workshop. I mean, I'm obviously the kind of nerdy person who knows how to use these things, but I hadn't been using it at all. And then someone said, hey, check it out. And it really was sort of push button ready to go. And a lot of the people that we've asked to sort of walk us through their thing, they seem to have no problems picking up how to use it. There's a few gotchas where you can sort of, there's better, better ways to do it, but there's not, basic usage is pretty easy. There's when you join up you can also join our Slack channel, which provides an awful lot of help. So we haven't actually had a formal tutorial or demo or anything like that so far.